What's going on, chemistry dudes? We're going to start off this thing on calorimetry. I'm going to try to give you all the relevant data that you need to do all of the calculations yourself. I have a calorimeter here. It's a empty styrofoam cup. Actually, two of them, and I taped them together. I've got 100 milliliters of water. I've got a ball bearing on top of a hot coil of metal, a stove, and I've got a scale over here. So first thing I'm going to do is I'm going to measure the mass of my ball bearing. I'm going to start that off by just kind of measuring this crucible and then pressing, wait, let me make sure that we're using grams. I'm going to zero that out. I'm going to get the measurement of mass of my ball bearing. It is 16.4 grams. Now, I'm going to press 0 again, measure the mass of my empty styrofoam cup. It is 10.9 grams. Huh. The styrofoam cups was only 6 grams smaller than the ball bearing, really? Huh, interesting. Then I'm going to put 100 milliliters of water in here. It is 108.7 grams. So from that you can figure out exactly how much water is in there. The other things I need is the initial temperatures of everything. So I'm going to start this computer up. Let's press play here. Play. There we go. And I'm going to get me the temperature of that ball bearing that I measured. Let's see. You can see the graph just shoot up like that. Let's see how high it gets. It's hard to keep this thermometer on top of this ball. All right, here we go. Oh, let's keep going around. Come on, give me a nice temperature. There. All right, here we go. That temperature is just look at it real quick. I'm going to say 167. All right, next thing I'm going to do is I'm going to get the temperature of my water. So then my water drops that temperature down to be, see how it dropped down? It went up and then went down. And the water seems to be leveling out at 23.5. Let's say 23.5. All right, so now what I'm going to do is I'm going to take that ball bearing and I'm going to drop it inside of the water. Let me just start a new graph. Okay. Take the ball bearing and I'll drop it inside the water. Here's what the graph looks like. Can you see that? There, that would be right. All right. I'm going to drop it inside the water. Got my thermometer on. Put this thing over here. I'm going to taper down. Okay, so you can see that it looks like it was at the temperature of the water, then it skyrocketed up, and then it went all the way up over here. It's kind of dying down and going straight across, and we'll see how this thing works. Let's see if it goes down to, what I'm curious to know is if it goes down to, so right now what's happening is the ball bearing itself is losing energy, and the water itself is gaining energy. So the ball bearing is getting colder where the water is getting hotter. And it looks like it's kind of going up. What's going to happen is they're going to reach a point where the water is going to get to the same temperature as the ball bearing itself. I'm wondering why it had this huge spike right here. And that spike went all the way up to like 27 or something like that. So it's not that gigantic of a spike, but I'm thinking that the reason why it had this huge spike, my thoughts is because maybe the ball touched the thermometer real briefly. Maybe when I dropped it in, it bounced off the thermometer, and that might have caused that spike. So now what's happening is it's kind of curving off, and I think eventually what's going to happen is it's going to die down. So I'll pass this data on to you, and you guys can pull it up on Excel or something like that, and then tell me what your thoughts for this experiment is. All right, cool.